Hi, welcome to Sakamuta Online Academy, the Academy of Excellence and Positive Results. Once again, please you can catch us on our YouTube channel. Simply type Sakamuta Online Academy, then you'll be able to get hold of the channel. And you can also follow us on our Facebook page. Simply type Sakamuta Online Academy or Sakamuta Manual, then you'll be able to get hold of the page as well. Please check the content that we post there. It's amazing. You'll be able to learn a lot of things from there. This is physics. Welcome to today's session. Let's set the ball rolling. Now, today I would want us to discuss a very simple topic in physics, and the topic is I would want us to look at distance, displacement, speed, velocity, and acceleration. Distance, displacement, speed, velocity, and acceleration. This is what I want us to look at today. Now, in order for us to be able to appreciate this topic, first we need to quickly look at the meaning of these terms so that even as we apply them, we'll be able to know what we are really talking about. All right, so distance has been defined in so many ways. One of the ways in which distance has been defined is that distance is simply a dimension space between 2 points. It is one dimension space between 2 points, and it is measured in meters. It is measured in meters. And please take note that distance is a scalar quantity. And distance is a scalar quantity. Another terminology that we need to be familiar with is what we call displacement. Displacement is simply the distance moved in the specific direction or distance moved in a straight line between 2 points. It is also measured in meters. It is also measured in meters. And take note that displacement is a vector quantity. And remember, I took time to explain what scalar quantities are and also what vector quantities are. So look out for that video. Just go on my YouTube channel. You'll be able to find it. All right, so let's take an example. Let's say a car traveled from point A to point E along a curved path A, B, C, D, E. What is the total distance and displacement traveled? So this is the curve that we've been given, A, B, C, D, E. This is the curve. All right, so in this case, therefore, the distance traveled by the car is the total distance, which is A, okay, the total distance A, B, C, D, and A. All right, that's the total distance. Now the displacement traveled by the car is going to be A to E, because we defined displacement as simply the distance moved in a specific direction or distance moved in a straight line, okay, between 2 points. So the straight line that we have here is A to E. So AE is the direction of A. So AE is the displacement that we are looking at here. All right. So another terminology that you need to be familiar with is what we call speed. Speed. What is speed? Speed is simply the rate of change of distance moved with time. This is the rate of change of distance moved with time. And we know that it is expressed by the equation S is equal to D over time, where S is speed, D is distance over time taken. So where S is the speed in meters per second, and D is the distance moved in meters. So meaning that if you're given, let's say, the distance in meters per, kilometers per hour, there's need for you to convert that to meters per second. And we shall look at things like that very soon. All right, so like I said, that the SI units for speed are simply meters per second. all right, meters per second. And we also know that speed is actually a scalar quantity. Speed is also a scalar quantity. All right. Okay, let's take an example. A car moved due east a distance of 40 kilometers in 1 hour. Find its speed, that's A. B, find its velocity. I'll read it one more time. A car moved due east a distance of 40 kilometers in 1 hour. Find A, its speed, B, its velocity. It's a velocity. Now, how do you go about this? All right, so there what you need to do is to look at the formula for speed. And remember, I gave you the formula that speed is equal to distance over time. So let's have our data. Distance is given as 40 kilometers per hour. All right, and time is given in hours, which is 1 hour. All right, so what should we do? All right, if you want, you can simply convert the kilometers to meters, and then also the hours to seconds, and then from there you do it direct. But if you want, you can also go straight where you have to simply to divide. Here distance is 40 kilometers over 1 hour, and then you divide, you get the answer, and then you convert now this answer to meters per second, because speed is measured in meters per second. So let's see how we can do that. Now we're saying that speed is equal to distance over time taken, and speed is equal to, so according to data given here, our data, we are given that distance is 40 kilometers, and time is given as 1 hour. All right, so what should we do here? So this speed here is equal to distance over time. Distance is 40 kilometers. 40 kilometers over 1 hour, like this, and when you divide, you simply get 40 kilometers per hour. Right, per hour. I can even use a small h here. All right, so that's the speed. Now remember that speed should be in meters per second, not in kilometers per hour. So meaning that there's need for for us to convert this to meters per second. Now how do you convert? Now so you're converting this 40 kilometers per hour is equal to, you simply get the same 40 and multiply it by 1000 meters, all right, over 1 hour. And this 1 hour can be converted to seconds, because 1 hour is simply in terms of seconds, because minutes it will be 60. All right, so 60 by 60, this will be in seconds, and therefore 40 by 1000 over this times that, it becomes, all right, it's going to be, in fact, here it's going to be in terms of seconds now, 3600 seconds, and this is going to be, all right, so once you say this times that, you have how many zeros? All right, you're going to have 4 zeros over 3600 seconds, and then you cancel these 2 zeros, you're going to have 40. All right, just cancel 2. All right, okay, you're going to have 40 or 400 over 36. So if you do some division there, or what you're going to get is simply 11.1 meters per second. So that's what you're going to get. That is what you are going to get. So that's how you convert. So meaning that now our speed, therefore, our speed is going to be 11.1. Speed is equal to 11.1 meters per second. So this is our speed. All right. So hope that helps. The question 2 is saying find also its velocity. Find also its velocity. Now, velocity is simply the rate of change of displacement with respect to time, or the rate of change of velocity moved with time in a specific direction. That's what velocity is about. So in this case, therefore, we can also say that velocity is going to be speed over time taken. So velocity, speed still remains as 40 kilometers over time is still 1 hour. All right, so this is going to give us 40 kilometers per hour. Now, velocity, just like speed, is measured in meters per second. So we need to convert this to meters per second. So velocity is going to be 40 kilometers per hour multiplied by, all right, 1000 meters, everything over 306, 3600 seconds. All right, this is seconds, and velocity is going to be, all right, so this times that, you're going to 40000, right, over 3, right, 600, and velocity is going to be, these two will go, and you're going to 400 over 36, and velocity still gives us 11.1 meters per second. All right, so that is also the velocity of this particular, as a velocity at which this particular car was moving at. So that's how you also work out questions of that nature. So please pay attention to the units, and where there is need for conversion, please do so. All right, so let's go ahead. Now, this time I want us to look at acceleration now. Acceleration. What is acceleration? Acceleration is simply the rate of change of speed moved with time in the specific direction, or simply the rate of change of velocity with time. This is simply the rate of change of velocity with the time. And therefore, the formula for acceleration is that acceleration is equal to final velocity minus initial velocity over time taken. So where v is the final velocity, so this v here is the final velocity, and u is the initial velocity, and t is simply the time taken. All right. Now, please remember also that acceleration is measured in meters per second squared. Acceleration is measured in meters per second squared. So take note of that. Those are the standard units of acceleration. Let's take an example. Let's say a car accelerates from a velocity of 2 meters to 5 meters in 2 seconds. What is the acceleration? What is its acceleration? What is its acceleration? So remember, acceleration is equal to velocity, final velocity minus initial velocity over time taken. And from our data, from the information given here, we can come up with our data. And final velocity happens to be 5, because this car was moving from 2 meters per second, which was the initial velocity, to 5 meters per second. That was the final velocity. So the final velocity here is 5 meters per second, and the initial, it was 2 meters per second, and time is given as 2 seconds. So what is its acceleration? So simply substitute here. Acceleration is equal to final velocity is 5 minus initial velocity is 2 over time taken, which should always be in seconds, 2. and 5 minus 2 is 3. Okay, 3 over 2. So acceleration is equal to, all right, 5 minus 2 over 2. And acceleration is going to give us 5 minus 2, 3 over 2. And therefore, acceleration becomes, listen to that, it gives you 1.5. So meters per second squared. So that is the answer. That is acceleration. That is how you find acceleration. All right. So sometimes they can ask you things like average speed. So what is average speed? Average speed is simply the rate of change of total, distance covered with the total time taken, and it is expressed as the average speed is equal to total distance covered over total time taken. So please take note of that. We might use that going forward. All right, so this is how you calculate problems involving distance, involving displacement, speed, velocity, and acceleration. Now, sometimes the information that you've looked at can also be represented in a graph. It can be given in a graph, and then where they ask you to, calculate and things like that. So it's better that you need to be familiar with the, graphical representation of such kind of information. So therefore, this brings us to now our next component, which is a graphical representation of motion. Graphical representation of motion. So under here, we'll look at distance stroke displacement time graph. We shall also look at other things. Now, before we go any further, I want us to look at this graph that we have here. And just look at this graph that we have here. All right, so this graph is very, very important for you to understand. So this graph is telling you, for example, we have distance here, which is in meters. We also have time here, which is in seconds. So A to B represents an increase in the speed. A to B represents an increase in speed. So AB represents increase in speed, and BC represents a stationary object. BC represents a stationary object. And CD represents decrease in speed. CD represents decrease in speed. So please take note of that. We shall be using that a lot, especially as we move ahead. All right, so that's that. Now, please take note. AB can also represent, constant acceleration. AB can also represent constant acceleration, and BC can also represent constant, velocity, constant velocity BC, and CD can also represent deceleration. So it's deceleration or retardation, CD. So take note of that. Now, to appreciate this, we need to look at an example. All right, so use the time graph below to find the following. So this is the time graph that you're given. In here, you have distance in meters. Under here, or in the x-axis, here, this is the x-axis. We are given time. All right, in the y-axis, we are given distance in meters. All right, so the questions are A. All right, find the distance covered by the car in 2 meters, in 2 seconds. All right, the distance covered by the car in 2 seconds. And B, the distance covered by the car in 6 seconds. Distance covered by the car, that is C, in 8 seconds. And then D, the speed of the car in 2 seconds, and then finally the speed of the car in 8 seconds. Now, how do you go about this problem? Simple. So the distance covered by the car in 2 seconds. Now, look at the distance. This is 0, 2 is here. So the distance covered by the car is, look at where the 2 is, up to here, and then make it 10. Right, so you discover that it is 4 meters. Just 4 meters. That was the distance that was covered in 2 meters, in 2 seconds, rather. Distance covered by the car in 6 seconds. So again, you go to a 6 is here, and if you make a dotted line, discover that it's here. So when you follow it like this, you come to a point where you have 4 meters per second. So it gives you, it becomes 4 meters, not per second, because it's distance, so it has to be in meters. So it becomes 4 meters. So follow it, 6, follow it like this, and then find where the distance is, which is this, and that becomes your distance. So 4 meters. Now, how do you find the distance covered by the car in 8 minutes now? Okay, so from 0 to 8 meters. So here you simply add the two distances that you have found. All right, so you simply say simply say 4 meters plus 4 meters, and this is going to give you 8 meters. So this is the distance that was covered in 80 meters. This was the distance that was covered in 80 meters. D, speed of the car in 2 seconds. The speed of the car in 2 seconds. Now here you need to come up with the formula now. Now remember, say that speed is equal to distance over time taken. So speed is going to be, now our distance in 2 is this one here. So here. So you have 4 over time taken. We're told it's 2. So speed is going to be, all right, 4 divided by 2, this is 2, okay, meters per second. All right, so this is our D. All right, let's come to E. Let's come to E. All right, so what is our E? Our E is saying that find the speed of the car in 80 seconds. All right, so again, you use the formula. Speed is equal to distance over time. So speed is equal to, what is the total distance? The total distance was found to be 8 meters. That is in 80 seconds. So we have 80 meters over, what is our time taken? All right, our time taken, I thought it's 8. So it's 8 seconds. And speed is going to be this into that 1. So meters per second. All right, so 1 meter per second. This is the speed that we have now. So this is how you calculate questions of this nature. This is how you calculate questions of this nature. All right. All right, so as usual, let's move ahead. We see how far we can go. Now, this time around, I want us to advance it a bit. I want us to advance this a bit. I want us to look at this time graph also that we have here and see how best we can calculate these questions. All right. So this is what I was trying to explain, that AB can also represent acceleration. All right. AB can also represent constant acceleration, AB, and BC can also represent, constant velocity, and DC can also represent deceleration or retardation. I talked about this. All right, so don't get surprised. Let's take this as an example. Let's take this as an example. So the graph below shows a velocity of an object along a straight road. The graph below shows a velocity time graph of an object along a straight road. So as usual, the x-axis shows you the time, and the y-axis shows you the velocity, which is in meters per second. So the question is saying, what is the total time of the graph? What is the total time of the graph? I don't think if anyone can fail this. So the total time of the graph is given as 80. So 80, all right, seconds is the total time of the graph. See. All right, B, what is the maximum velocity of the graph? What is the maximum velocity of the graph? So the maximum velocity of the graph here is 10. So the answer is 10 meters per second. 10 meters per second. All right. Next question. What is the acceleration during the first part of the journey? Excuse me. What is the acceleration during the first part of the journey? All right. So as you know, that acceleration is equal to final velocity minus initial velocity over time taken. So our data, what we have is that, all right, excuse me. All right. So our data, as you know, that the final velocity is 10 meters per second here. All right. Our time, okay, our initial velocity. This particular car started from rest, so it started from 0. So meaning our initial velocity is going to be 0 meters per second, and then our time taken is going to be, all right, the question is saying that in the in the first part of the journey, so the first part is this one here, so this is going to be 20. That is our time, because the first is this one here. So this is the first, second, third, and so on and so forth. So time is going to be 20 meters, sorry, 20 seconds. So therefore we say now that acceleration is equal to final velocity is 10 minus initial is 0 over time taken is 20, and therefore our acceleration is going to be 10 over 20. 0 and 0 cancel, and therefore we have 1 over 2, which is simply 1.5 meters per, is it 1.5 or 0.5? 0.5 meters per second squared. Right. So that becomes your acceleration. C. What is the deceleration during the last part of the journey? What is the deceleration during the last part of the journey? Now, deceleration is always negative. It should always give you a negative. All right, so we use the same formula for acceleration, which is final velocity minus initial over time taken. So in this case, therefore, since we're finding the deceleration, and by the way, this is C, since we're finding the deceleration, okay, what you're going to have now is a situation where where the deceleration here, now the final velocity is going to be, all right, 0 minus the initial is going to be, is going to be 10. Let's go back to the question again. What is the deceleration during the last part of the journey? During the last part of the journey. All right, so yeah, good. So our final velocity is going to be 0 minus our initial velocity is going to be 10 over our time taken. Our time taken, therefore, is going to be here. The difference is 0 from 0 to 20 is 20. That's the difference. So 40, between 20 and 40, the difference is 20. Between 40 between 40 and 60, the difference also is 20. And between 60 and 80, the difference there is 20. So this is going to be 20. So acceleration is going to be, deceleration rather, is going to be negative 10 over 20. And deceleration is going to be negative 1 over 2, which is going to be negative 0.5. So this is going to be our deceleration. This is going to be our deceleration. Okay. Next is calculate the total distance covered by the car. Calculate the total distance covered by the car. Now here we look at the graph. We look at the graph. What shape is this? This is a trapezium shape, and you know the formula for trapezium. You know the formula for trapezium. So distance is going to be 1 over 2 a plus b, and then height multiplied by height. That's the formula for trapezium. So distance is going to be, the total distance covered therefore is going to be 1 over 2. All right, what is our a? Our a is simply this is actually, now from a is actually, this is our a, and this is our, from here to here, this is our b. So our a is simply do this. All right, you do this. So our a is going to be 40, so to say, because from here to here is 20. So 20 plus from here to here is 20. So 20 plus 20 is going to give us 40. Plus our b is from here to there, which is 80, which is 80 multiplied by our height. Our height therefore becomes our 10 here. Our height, the velocity becomes the height. So it becomes 10. And then we'll do some simple mathematics here now. Distance is going to be half. This plus that. This is going to give you, so this is 40. All right, so 80 plus 40, 80, 90, and 100. You know, it's going to give you something like a 120. Is it? 120 times 10. Distance is going to give you this into that. That's going to be 5, and distance is going to give you 600 meters if you do what you multiply there. Let me just confirm if what I've done is correct. All right, so what you're saying is multiplies. Right. All right, so you're right. This is the answer to that. All right, so this is how you calculate also questions of this nature. SAS one and the same thing that you're doing here. All right, so for today we end here. We shall continue with the equations of accelerated motions in our next video. Thank you.